Greetings and welcome, friends. Mr. Waddy here, showing you some midpoint and distance formula stuff from a geometric perspective. It's going to be some good stuff. You might recall some of this, maybe even from Algebra 1, Algebra 1-dom back in the day when you were in a different kingdom altogether. But here we go. So midpoints and segment bisectors. Okay. So the midpoint of a segment is the point that divides the segment into two congruent segments. All right, so for any segment, you can imagine a point such that where it is placed divides it into two equal parts. So in terms of language, so this is the definition of midpoint, which, by the way, def of MP will be something we'll have to refer back to later on when we're doing proofs, which I look forward to. It'll be great. So M is the midpoint of AB. That's how you could kind of symbolically write it. So, or therefore, AM is congruent to MB. And if they are congruent, therefore, their measures or their distances are equal. All right, so it's possible to have a midpoint that does that, dividing it into two congruent segments. And then here's the language. A segment bisector is notice it can be a variety of things, a point, ray, line segment, or plane that intersects the segment at its midpoint. A midpoint or segment bisector bisects a segment. Bisects two, for the word, right, prefix bi. It dissect, right, is to kind of pick it apart. So it bisects it because it cut it into two equal parts. So in this case, you could say that line, notice the symbol there, you got the double arrows there. Line CD is a segment bisector of AB. I also could have said that, I could have said point M is a segment bisector. I could have said that ray MC is a segment bisector. Actually, whoa, I just realized something, guys. If I only put half of the arrow head on that, this is actually mathematically referred to as a vector, which you might see maybe pre-calculus, algebra 2, I don't remember. So yeah, the double arrowhead, or the complete arrow, so to speak, is actually significant, right? So it could be a ray, could have been ray MD, could have been segment CM, lots of possibilities. So therefore, AM is congruent to MB, and AM is equal to the t'other one. Let's see, did I already miss my lesson here? Oh, guys, how embarrassing. Here we go, found it. All right. All right, let's do an example. I love it. Classic math books trying to be hip. Check this out. Check out this example. Find the segment lengths in the skateboard design. Oh, yeah. These math books are so hip. They know how to relate to you kids. Let's see, where's my mouse at? It's up there somewhere. Bam. All right, so here's a skateboard design, something like that. Looks like they've got a little bit of shading on this end here, implying that there's a lip on that skateboard when you're ready to, what is it, ollie? Yeah, I don't know. So let's see, in the skateboard design, VW, just so we're aware of what we're talking about, that's this segment right here, V-dubs, bisects XY at point T. So there's XY bisected at point T. All right, and XT is 39.9 centimeters. So XT right here, 39.9 centimeters. So the question is, find XY. All right, so this problem arguably is simpler than what I'm going to demonstrate, but I want to point out the logical progression using the things we currently know and or can prove. So I know that this XY segment is its measurement, its distance is going to equal XT plus TY. All right? Why do I know that? Segment addition postulate. All right, I know that xt is going to equal ty. Tell you what, I'll even write some justification here. I'm going to write seg add post postulate. All right, why do I know that xt is equal to ty? Because, right, definition of segment bisector. Def of seg bisector. Okay? So logically I could make that claim. Next, I would argue that I can take this and plug it in there. So I'm going to have xy is equal to xt plus xt. Why do you think that's true? Substitution property of equality. All right, so that's going back to your Algebra 1 days right there. So we've got geometry and algebra kind of coming together as best friends in a buddy cop movie, solving this problem about skateboard crime. Maybe. Skateboarding isn't a crime is what I've heard on bumper stickers, though. And let's see, so 39.9 is the length of xt. So I could say xy is equal to 39.9 plus 39.9. That's another substitution property of equality. And I'll get xy is equal to, looks like 79.8. Now, arguably, I bet you could have gotten that answer rapido. Right? I think you could have just been like, oh, I just doubled it. Or I just added to itself, and I'm done. But I wanted you to at least see some of the logical justification for why I know that it's true. Okay, so those were the claims that I was making there. Let's see. I think I'm going to skip that. Let's just go right to this one. I like it. I like it. I've got my selection of problems over here on my side screen. I'm like, yeah, I like that one. That's good. Yeah, so I've got my tastes as a geometrician. I'll skip on some of these. Let's see, example dose. Point M is the midpoint of V dubs. Okay, all right, makes sense. Find the length of VM. Now, it's good to, when you read something, all right, when you read a claim, to either draw a sketch yourself or label the sketch yourself. Notice they already did. They labeled it congruent. Why are these two segments congruent? Def of MP, definition of midpoint, right? So labeling the information that you're reading, okay? And then it says find the length of VM. VM is this one. So that's the length that I'm looking for right there. And it looks like there's some values of x in here. That's okay. So the length of VM will likely be written in terms of x. Okay? So let's see. If M is the midpoint and these two segments are congruent, therefore, I'm going to say that VM is equal to MW. Actually, my initials are BMW, although I'll never own a BMW. But there you go. Side note, Mr. Waddy facts. Not that Brian Waddy already wasn't a sufficient way to narrow me down as a unique individual on the planet, the only one. But now you know even a little bit more information. I'm not ever going to do math problems with my social security number. Or wait, now if I make that claim, you could just exclude all other numbers that I use, and then by process of elimination, discover my social security. And then that wouldn't be good. So maybe I'll slip it in there someday and you won't know. Yeah, so I'll have to keep it in the mix, like just stay on your toes. So let's see, substituting. Let's take this guy and throw that in for VM. Let's take this guy and throw that in for M dubs. Oh, guys, I think we're going to be able to solve this. Yeah, we're going to be able to solve for x, friends. I like it. All right, so I'm going to have 4x minus 1 is equal to 3x plus 3. And now in order to solve, maybe it's been a while, I've got variables on both sides of the equal sign. I like to move the little guy to the big guy when it comes to my variables. All right, so I've got 4x and 3x. Who's the little guy? 3x, right? So to move a positive 3x, I'm going to subtract 3x from both sides. 4x minus 3x is good. Some people want to say 1. They assume that the x's subtract. But remember, this is like 4 apples minus 3 apples. It's just an apple. It's still an apple. It didn't like lose its appleness, right? I'm thinking of like Apple Jacks commercials from the 1990s now. And 3x minus 3x is 0x's equals to 3. Yeah, why don't they taste like apples? I don't get you kids. You and your skateboard math problems. I don't get this generation. Let's see, add 1 to both sides. Tradition, property of equality. I can maintain equality by adding the same thing to both sides. X equals 4. Now, I'm ready to box that like final answer, but no. No. What am I looking for? I'm looking for VM, right? So I'm going to have to sub again. This problem ain't done. If x is equal to 4, therefore, I can substitute it in right there. 4 times 4 minus 1, VM is equal to? Man, my writing is terrible. 4 times 4 is 16 minus 1. It looks like VM, it looked like an R for a minute, is equal to 15. And these we don't have units for, that's fine. We're cool. We're good. I don't need units. Wow, good problems. I might show you this picture just as like a little break from the straight math. I'm just going to show this to you all in one go, and we'll just talk about it. And you can imagine with paper in your mind and fold it in half. It'll be pretty good. All right. All right, check this out. Constructing bisecting a segment. So we were just doing some constructions. I showed you kind of a tricky way to create a midpoint, right, to find half the length of a segment just a moment ago in class. Imagine if I had a segment AB, I could draw it on a piece of paper. I could fold said paper lining up point B on top of point A, and the idea of folding it and then creasing it is going to, in fact, cut that segment in half. When I unfold it, I could label that point M, and that's the midpoint, my friends, right? Seems to make sense. Maybe that's what you were supposed to do on the last one, but I'm fine with that. Now, we have been, as I'm switching gears here, we've been talking about geometry so far, primarily with like these pictures and these sketches, but sometimes we have a coordinate plane, sometimes we don't. We're going to apply these same concepts on a coordinate plane, and there's really, I mean, geometry is geometry, but there's this idea of Euclidean geometry. Often is kind of when you're imagining things without a coordinate plane. We're just applying these properties of segments and angles and triangles and all sorts of things. And we don't necessarily need a coordinate plane, but the same things apply if I do put it over a coordinate system. So here's the midpoint formula. You might remember this from your algebra days or pre-algebra. And if I have points A and B plotted on an XY grid, I have their coordinates, a horizontal component and a vertical component, right? Over X1 up Y1 and over X2 up Y2. And I can plot those 2 points. And if I wanted to find the midpoint between them, this is how you could do it. All right? So let's see. The coordinates of midpoint and segment are the averages of averages. I like this. of the x coordinates and the y coordinates of the endpoints. So if A is at x1, y1, written in generic terms, okay, normally these x1, y1s, x2, y2s will be individual numbers or expressions, okay? If I wanted to find the midpoint, what I would do is find the average of the x's and the average of the y's. And then I'd write that in a new coordinate. So here's like my macro parentheses, comma. So my new x coordinate is x1 plus x2 all over 2. Because in general, average means the mean. And to find the mean of a set of numbers, you add them up and divide by how many there are. In this case, there are 2 points. All right, so x1 plus x2 divided by 2. And for the y coordinate, you do y1 plus y2 divided by 2. Notice the orange sketch here. If I've got x1 and x2 divide by 2, that's going to give me the midpoint here, which if we trace up gives me this location. And for the y coordinates, if I do y1 plus y2 divided by 2, it gives me the midpoint of their vertical components. And if I trace that across, the intersection of those two things will be M, the midpoint. The midpoints. Ooh, I like it. Here we go. Whew, guys, how about this heat? My goodness. It's tough doing this math. Well, later on, you could go back and watch this video in an air-conditioned room. Just relax like you would watching math videos. So really, the formula you need to know is this one. MP is equal to, and it's an ordered pair. So let's throw this into an example here. The endpoints of RS are the following. Let's label this x1, y1, x2, y2. It says find the coordinates of midpoint M. Now, I've got a formula. I've labeled this. I don't have to draw a picture. If a diagram will help you, if plotting those points will help you, go for it. But you do not have to. All right, so I'm going to take my midpoint formula, and I'm just going to plug these in. So I'm going to have MP is equal to the average of the x's. So 1 plus 4 divided by 2, comma, and the average of the y's, negative 3 plus 2 divided by 2. All right, and 1 plus 4 is 5. And negative 3 plus 2 is negative 1. And here's the midpoint written as a set of improper fractions, but you could also represent that 2.5 comma negative 0.5, right? Something like that. So that would be our midpoint. Most of the time, by the way, I'm a fan of the improper fractions, but I understand for graphing using a mixed fraction or decimale might make more sense. Can be easier to graph, no doubt. Let me show you this other slight modification. Right, so far that's just plug and chug. All right, here, same idea, same formula, different information. And so what I've got is the midpoint of JK. They gave us the midpoint. I don't know, I could label this M sub X and M sub Y. I don't know, I just made those up. But it might not be a bad idea to have labels. One endpoint is, so let's call this X1, Y1. It says find the coordinates of the other endpoint, which let's call X2, Y2. So this time I know some of the information, not all of it. And actually when I write this, where's my cursor at? There we are. Wow, that fan. It's okay. So when I write this, I'm actually going to break the midpoint formula into two separate things. So I'll have mx is equal to the average of the x's. And my is equal to the average of the y's. And we'll just plug in what I know and solve for what I don't. which, by the way, that's like if I was like a Toy Story Woody style character doll thing with a pull string on my back, and you pulled that string, one of the phrases I would say is plug in what you know and solve for what you don't. Like that's one of the things I would say. I'm pretty sure. Right? Like it's just classic algebra, friends. It's classic. Also, I don't currently have a merchandise portion of my YouTube channel, but maybe make some requests in the comments, and maybe we'll have the audience, the outcry, the public outrage that there's no WadiCon that you could go to buy a bunch of merch. Maybe it'll just have to happen. I don't know. It's a possibility. So let's see. Let's plug in 2 equals 1 plus x sub 2 all over 2. And I'll just simultaneously plug in over here. So I'll have 1 equals 4 plus y2 all over 2. This isn't the only way you'd have to do this. You might be able to, in your mind, think of a less algebraic approach. You kind of just could have like reverse engineered some of this maybe. You can even theoretically do this a little bit graphically, which I find interesting. Maybe I'll show you a picture of that in a moment. But to solve for what I don't know, this is all being divided by 2. I would multiply both sides by dose and tell you what, it's the same step. Let's just do, you guys always solve 2 equations at once, don't you? 4 equals 1 plus x sub 2, and 2 equals 4 plus y sub 2. And you guys can probably tell we're just going to subtract 1 from both sides here and subtract 4 from both sides there. And I'll get my point at x2 is equal to 3. And y2 is equal to -2. And then I could even represent that just as an ordered pair. My endpoint is going to be 3, -2. Right. Let me show you a sketch of this. Do we agree, disagree? Does it make sense? Maybe. All right, so here's another way you could kind of think about it, but I still want you to do it with some numbers, not just with the graph. If I plot my points, I know that there's an, if this is a midpoint, here's an endpoint, I know that the other endpoint must have been on the other side of this midpoint. One of the ways you can do this is using slopes, kind of. Notice to go from this, I go down 3 and over 1. And so to find the other point, I could just go down 3 and over 1. And that actually would have landed me at the right location of, yeah, just looking at the y-coordinates, 4 minus 3 was 1. 1 minus 3 is -2. And then the same for the x-coordinates. 1 plus 1 was 2, right? I went over 1, so 2 plus 1 is 3. And I get the same solution, but that way you've got kind of a visual representation, like such. Let's talk about distance formula. Distance. You guys, I think we've talked about the Pythagorean theorem one day, briefly, like just aside. You probably remember it, have it memorized from your middle school days. Probably like we're just talking about the Pythagorean theorem at lunch like you do while you were skateboarding. You're like, hey, how about that Pythagorean theorem? But here we go. Distance formula is actually a derivation of, it's related to, they say, the Pythagorean theorem. So here's the distance formula. You guys probably should have this memorized. It's a good idea. It's going to show up for the rest of your lives. You'll use it every day at work, every day. Like if you get married and have a family, like you'll be just all the time. When you're driving to work, when you're like voting and you've got to figure out who you're going to vote for, distance formula, all the time. Like I just actually, when I like fill in bubble sheets when I'm voting, I just kind of like pick a distance and then I Just fill in all the bubbles that are that distance apart from one another, and I'm good. So yeah, all the time. Classic distance formula. So here, once again, it's based on coordinates. To find the distance, they actually find the distance between the x's, which is represented by the absolute value of their difference. They find the difference and absolute value it to make it a distance for the y's. And so you end up with two components. I'll call that A and B. And then to find the diagonal distance, really you're just doing some A squared plus B squared equals C squared, friend. It's really all it is. And if I'm thinking about it in that context, you can see where they've derived it. So, right, if this is A and I plug that in here, and if this is B and I plug that in here, right, I'll get x2 minus x1 squared plus y2 minus y1 squared. Thoughts? Question. These had absolute value. Why don't these have absolute value? What does absolute value do to a number? It makes it positive. If it is positive, it stays the same. Why do I no longer need to make this positive? Thoughts? Because it's squared, and you might remember that squaring a negative becomes positive, and squaring a positive will still be positive. So it would actually be redundant, as they say, if I had to keep having that absolute value there. So they were able to drop it. And then, so this AB squared, the diagonal squared, is equal to the square of that difference plus the square of that difference. It's just Pythagorean theorem. And if I want to solve this equation for AB, what could I do to both sides? Root both sides, my friend. And arguably, algebraically, you'd always remember the plus or minus. However, we're talking distance, which is only ever going to be positive. So geometrically speaking, we'll ignore that negative. We exclude that as a potential answer. So that's where the distance formula comes from. It's just the Pythagorean theorem, but this is what you need to know, right? That is what you need to know. So memorize that at some point, right? The square root of x2 minus x1 all squared plus y2 minus y1 all squared. There's like a little bit of symmetry to it as well, right? So yeah, you're good, you're good. Let's see, thoughts, question? Let's get one example in here. Man, ay, 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 tiempo, my friends. Okay, here we go. Your school. Here we go. Little word problem. You don't have to write this all down. Maybe you could start by drawing a sketch. You don't have to. All right, yeah, we're approaching 28 minutes on this video. We gotta get cruising here. All right, so it says your school is 4 miles east and 1 mile south of your apartment. A recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. Estimate the distance between the recycling center and your school. Now, when they gave these distances, it was always in reference to your apartment, right? To your apartment. So if I wanted to map this onto some coordinate system, wouldn't be a bad idea to think about it in the context of my apartment being the origin, right? If that's what I'm measuring from. So here's like a little graph they made. I know they're like trying hard to turn a math problem into a real world problem here, but they're trying, guys. They're trying. Give them, you know, props for trying. So notice if this is where our apartment is, the recycling center is 2 miles east and 3 miles north, denoted by this point. And la escuela is 4 miles east and 1 mile south, and like so. And if I want to estimate the distance between those two things, assuming it is as the crow flies, a straight line. Maybe you've never heard that phrase, but that's what it means, like in a straight line. Because, you know, as the person walks, we don't always have the ability to walk in a straight line because of like things get in our way. Whereas a crow, it's just like, psh, living the easy life, shortest distance, Just fly over my problems. So let's find this distance. So RS, recycling to center to school distance, is going to equal the square root of massive square root symbol here. Let's label this. We'll label this. Oh man, that's not a good color. Let me pick a darker color here. Deep purple here. X1, Y1, and X2, Y dose. All right, and I'm gonna plug it in and evaluate. So the square root of X2 minus X1, so that's 4 minus 2, all squared, plus this, let's see, parentheses, Y2 minus Y1, so negative 1 minus 3, all squared. And now I just got to PEMDAS this, friends, right? Order of operations, parentheses, exponents, multiply, divide, subtract, that thing. You can go actually watch my other video I just recorded Friday for Algebra 1. Bam. You can go check that out. It's like, you know, recommended videos sort of thing. So let's see how it works inside the parentheses first. Square root of 4 minus 2 is 2, all squared, plus negative 1 minus 3 is getting more negative. 2 squared is 4, plus negative 4 all squared is positive 16. Square root of 20 is what I get, which, if I wanted to estimate that, you could get a calculator and get a pretty accurate result. Or square root of 16 is equal to 4, square root of 25 is equal to 5, 20 is closer to 20 is closer to 16 than it is to 25. So I'm guessing that the answer being somewhere between 4 and 5 is a little bit closer to 4. So I would squiggly equal sign this. I would have guessed like 4.4 or something like that. But your book says it's 4.5. So I'm going to go with their thing. And then you could like raise your hand and tell the teacher, hey, teacher, I think the school is 4.5 miles from the recycling center. And then like everyone's just like, what? No way. Like, that's amazing. And everyone would just be like so impressed. People would be buying you lunch. Man, you'll be picked for all the teams. Like, you'll be able to skateboard that distance and know how long it'll take because you know how fast you skateboard, miles per hour, and you know like the length of your skateboard now as well. So you could measure that distance in skateboards. You could. Like, you could just build a continuous bridge of skateboards that whole way, and you would know how many it takes. You're a problem solver, friends. Well, thanks for watching, Internet friends. Have a great day. Bye-bye.